Hello, computing friends. My name is Dustin C2, and I am the Director of Product Marketing here at Premio Inc. Thank you for taking time out of your busy schedules to participate in AI Day, but also tuning in to this specific section called Know Your Options when it comes to embedded AI systems and software. So although we at Premio like to believe that we bring most of our computers to life that actually can speak, as you saw in our introductory video, it does require a bit amount of engineering teams to understand electrical, mechanical, and reliability demands that go into our overall compute hardware and our solutions. But luckily for the past 30 plus years, Premio has put together a robust engineering team and a manufacturing arm in the United States that pushes forward our industrial computers for a lot of these enterprise grade deployments. So the focus of this presentation will be highlighting the most important hardware requirements for rugged edge computing. So I would like to start with a statistic from Gartner, and that statistic is 75% of data will be processed outside the cloud by 2025. I believe this is a very important statistic because it really highlights the value of where data is currently being processed and why there's becoming a massive shift out from the cloud to the edge by 2025. And that shift from the cloud out to the edge is extremely important in an element of edge compute because it's driving a new level of business intelligence, but really delivering real-time insights for a lot of these newer machine learning and artificial intelligence models. So I would say for the past decade or so, a lot of these technologies are really focused on fostering a growth and drive for this digitization of data. But I think the value of the digitization of data really is now moving into a value that's going to drive better results for smarter automation. So rather than focusing on the digitization of data, I think it's fair to say that the value of data is really moving into more automation and machine intelligence. And a lot of this demand for more automation is actually being pushed into new environments. And a lot of these new environments are not often controlled. They can be harsh, they can be remote, they can be mobile. And this is going to require an extreme amount of compute power that has been ruggedized, that could be reliable to basically manage a lot of these mission critical workloads, specifically at the edge. So from a Premio perspective, we like to ask a question. Are you specifically rugged edge ready? So you might be asking, what is the definition of rugged edge computing? So many customers or many industries are still in their own version of a digital transformation. And that digital transformation really is made up of an ability to access, collect, store, and analyze data. But it's this shift from the traditional cloud model to something that's more localized compute that's going to deliver the ability for real-time processing with connectivity that's able to drive new business insights with incredible speed and accuracy in these newer type of environments, conditions, right? So from a Premio perspective, rugged edge computing is defined by some key principles, and very simply, it is the convergence of the latest IoT technologies from compute, storage, connectivity, and most importantly, system level ruggedization to endure and provide reliability in harsh mobile and remote environments. So most importantly, with this decentralization from a lot of these cloud resources that by definition is going to drive more localized compute closer to where these IoT sensors are. And by having that localized compute in close proximity, you are able to now deploy machine learning and run AI models close to where data is being generated. So with the convergence of technologies and a decentralization away from the cloud resources, by definition, again, is going to require dedicated hardware and system level engineering that is balancing both the power efficiency, the ruggedization, and connectivity for the ability to process and store valuable data from IoT. Some of these solutions are made up of IoT gateways, industrial computers, rugged edge computers that are closely sitting next to these IoT sensors. So what are the technical drivers in edge computing? I would say the first technical driver would be heavily stemmed on the exponential growth of mobile and IoT applications. So in order to have mobile and IoT applications, a lot of the data that's generated from these stems from different endpoints, could be coming from Ultra HD cameras, IoT sensors, but most importantly, this data is packaged together to drive analytics models. And with the analytics models from the data, you are able to now require to store, process, and manage, protect this data. But having this overwhelming amounts of data creates now a challenge to map out the data pipeline. And that challenge is being able to access data at what time data and when to pass data for certain elements between the edge or the cloud. And by this all these new devices coming online, this is ultimately providing a massive demand for these low latency, high performance, more secure and scalable solutions that are able to now process large amounts of data and interact with the data and provide some type of insight in real time. So the second technical driving factor on edge compute is the understanding and realization of the cloud limitations. I think cloud itself is definitely not going to go anywhere. I mean, the centralized processing power in the cloud is always going to be reserved for these powerful deep learning AI models. But if you need to leverage those resources and able to do the real-time processing in some applications that require ultra low latency, say, for example, autonomous cars, factory automation, relying on the cloud is just not reliable enough in terms of the latency, but also it would just be too slow. So with these new edge computing workloads that require localized processing with incredible speed and accuracy, this is going to require these solutions to become ultra low latency, better bandwidth, more secure, and ultimately eliminating a lot of regulatory issues oftentimes seen with the cloud. A third technical driver would be these new capabilities of compute. A lot of the new technology is putting a lot of horsepower into these new type of multi-core processors that are able to deliver extreme amounts of processing power, but most importantly, are able to compute incredible amounts of data. So for example, a lot of these new capabilities in terms of compute are dedicated to specialized hardware that are able to run specific AI models for machine learning. And this includes a lot of hardware related to these GPUs, TPUs, and specific ASICs that are really pushing forward purpose-built intelligence specific for applications at the edge. So what are some solutions needed at the rugged edge from a top level? I would say number one would be a need for more localized processing to facilitate hyper-remote automation and real-time insights. When you are able to move all this processing power closer to the data, this is where you're going to really extract the value and really push forward the beneficial factors for machine learning and inference analysis that provides the real-time situational awareness through intelligence with the horsepower from a lot of these localized compute solutions. Second, it would be a need to support software advancements with hardware strategies that combine the latest technologies. So I would say software as a whole is oftentimes written with extreme amount of flexibility, which is extremely beneficial for applications. But oftentimes software and hardware are actually connected because the hardware drives the performance required to deliver the real-time performance. So a lot of these newer solutions that are packaged with these hardware acceleration models are system-level computers that deliver reliable performance in a variety of these close to IoT sensor environments. But the challenge there is when you're starting to move a lot of these localized compute power into these volatile environments, this forces engineers to really design outside their standard comfort zones, because lots of times these solutions are being deployed in foreign or uncontrolled environments. So one of the main factors is really being able to push and balance power efficiency and performance to a level to where it's still maintainable and reliable. A third would be a need for data center performance at the edge. So when we talk about data center performance, I specifically am talking about hardware. Some of the access for a variety of processing technologies that CPU, GPU, and even TPU for these dedicated processing within reasonable power efficiency is extremely important for these solutions at the rugged edge. In addition to that, having the ability to have high performance storage in real time with high reliable read and write speeds. So for example, lots of the storage media that's being deployed in these edge applications need to be able to access and store and read and write data extremely efficiently. So lots of times that is based upon the storage media protocol. So for example, NVMe, which is non-volatile memory express, is something that is still new, but being introduced into these edge computing markets to really deliver the low latency read and write performances that can benefit a lot of these edge workloads. So in summary, the solution that Premio is bringing to market that kind of consolidates all these different type of driving factors is our AI edge inference computers. These AI edge inference computers are hardened and ruggedized to fit for mobile and remote edge compute deployments. They also provide real-time processing and valuable data storage to really run the machine learning intelligence and inference analysis needed at the edge. And last but not least, it's really a consolidation of the latest compute, storage, and connectivity with ruggedization technologies to deliver robust hardware at the edge. So again, in summary, this is our RCO 6140 AI Edge inference computer that is being deployed specifically for our rugged edge workloads. One thing that is extremely unique about this product is that we are making this now a modular design. So as you can see, the top module of the product is still an industrial grade fanless rugged PC, and now offered with specific bottom modules that are dedicated for hardware acceleration, which we are calling our Edge Boost nodes. So each of these specific Edge Boost nodes can be deployed and fit for specific applications for hardware acceleration. Whether you need GPU, TPU, and even NVMe storage, you have that option to select through that Edge Boost node. Specifically in the NVMe drives, these NVMe drives are lockable, so they are secure. But most importantly, if you need to extract that data, you have the ability to really pull the data in an extremely fast manner through hot swappable canister bricks that can be pushed into a more centralized location for better data manipulation and actually to train machine learning models. From a ruggedization standpoint, this product also is wide operating temperature, and it also is designed to endure industrial shock and vibration. And then last but not least, connectivity is extremely important for data telemetry at the edge and how you have machine-to-machine communication, specifically in a lot of these remote and mobile environments. So this product is 5G ready through our proprietary daughter board that's able to deliver the ultra-low latency performance through these new up-and-coming 5G networks. So in summary, I would like to say thank you for listening to our presentation about hardware requirements at the rugged edge. If you would like more information about rugged edge computing or Premio itself, you can visit us on our website. That's premioinc.com. Thank you and have a nice day.